Hi, my dragons. Part 3, Research Methods Intro. And it is for the 22nd, not the 23rd. I put the wrong title on the last two. So it is January 22nd. Okay, so continuing on what we were talking about, converging operations and how they come together for us to determine the things that we're interested in studying on a particular topic. Another thing that can happen that is really cool is something called serendipity. And serendipity is luck. Okay, so you discover something else en route to something else. It's like when you take a wrong turn and all of a sudden you found the best bakery in the world. So you're like, wow, that was lucky. Okay, you weren't really looking for the best bakery in the world. You were looking to go someplace else. But guess what? You found something really good on the way to going someplace else. So that's a serendipitous finding. So we see this all the time in research. There's a lot of inventions, everything from microwaves to Velcro. A lot of things that were discovered accidentally when they were looking for something else. And your forum this week, you're going to, on Friday, the 22nd, you're going to be looking up a serendipitous finding and telling the class what your serendipitous finding was. You should do it quickly because I'm looking for non-duplicates. So everybody put your thinking hats on and find a serendipitous finding. We should have 13 of them, and not the ones that I mentioned in this video either. Okay, so the classic serendipitous finding is Pavlov. Pavlov is, just a guy, he's a physician, he's looking to understand digestion, and he's using dogs as his model. And so he's working with the dogs because he wants to see how food breaks down. And then he realizes when the dogs hear a bell, they automatically salivate, thereby throwing off his whole experiment. But he went on to discover, classical conditioning. Really cool kind of thing. Here's a really infamous, when I say infamous, I mean kind of shameful, but a shameful kind of finding. This is really finding the silver lining in a dark cloud. J.B. Watson, who was the father of behaviorism, okay, he was an esteemed psychologist at Johns Hopkins University, and he was really famous. He discovered a lot of really cool things, but then he had an affair with his graduate student, and that was made public, and he was, it was a scandal, and he was kicked out of Johns Hopkins for that. And really shunned by the American Psychological Association. It was terrible, big scandal. So here he is, he's a professor, he's a really famous professor, he's very skilled. What is one to do? Well, he went on to really lay the foundations for advertising. Because he was looking at what is it that makes people behave, differently when they see a product, And he became famous in advertising. So advertising owes a lot to John Watson, and John Watson wouldn't have even founded advertising if it weren't for his scandalous tryst. So I gave you a little infamous example. Another example along those lines is scientists were looking for heart medication, and a side effect gave us Viagra. So there you go. That was a serendipitous finding, and now people without heart problems wanted to take Viagra for the side effect. But again, that's very dangerous because you should really only take a drug for its intended purposes, okay? But there are even some fun things, right? Like here was this guy during World War II, and he was a mechanical engineer on I think he was in the Navy. And he's trying to figure some parts out, and he's got his stuff all over the floor, and his wife comes by, and she starts playing with a spring. And she's going like this with the spring. And that was the invention of the slinky. He made more with that little toy than he did in his real gig. So that was a serendipitous finding too. A really famous one. Well, of course, penicillin was a serendipitous finding too. One of you can take that and explain it to the class. Smallpox. Jenner noticed that, people were getting smallpox and dying. It was a real pandemic. It was terrible. And he noticed that milkmaids on a farm, they didn't get it because they got an analog disease. We call it analog because it's similar to the original disease and it's related but not as serious. So these milkmaids who spent their time milking cows, they got a disease, but it was cowpox. And then if they got cowpox, they were somehow immune to smallpox. So that set Jenner on his path for the smallpox vaccine. So there you go. That was a serendipitous finding. The same thing with the Pez dispenser, which was not intended for what it was, and then it became a really famous candy. So there's a lot of these, and I'm going to put a couple of things up there for you on serendipitous findings, but I want you for your forum to find something that you found interesting and serendipitous. There's a lot of them that are out there, and it's really fascinating, and some of you will be pretty surprised at some of the things that we found out by accident. I'm going to give you one more. Lionel trains. I don't know if you've ever had a train set when you were a kid. That started out in the East Coast. We have big department stores, and in the department stores they have all these really cool displays. It's like a real career to be a display person in a big department store like Macy's, Gimbel's, Filene's, all those big stores. And one Christmas they decided they're going to get people's attention by having a moving train, little train, itty bitty train, that went by, and each part of the train had a little saying on it like, on sale now. And each one had it, and it went by. Well, nobody paid attention to what they were saying was on sale because all the kids wanted the trains. And that's how we got train sets, okay? So that's really cool. I don't know about you guys, but when I was a kid, this is basically for, anybody who liked Barbies. Remember that Barbies had these, Barbie had everything. She was greedy. But if you ever went to a sports part of a department store and you saw like those little models of the tent, I was like, man, my Barbie's going to have a tent. They missed their calling. They should have sold those little tents and little sporting good, little miniatures of them, and they would have made a lot of money. That's another serendipitous finding. So there's a lot of them, and that's going to be your forum for this week. So good luck hunting that. Going back to what we're talking about. So that's serendipity. Sometimes things happen. You might have that happen in your research. You think you're going to look for something, and you're looking to show, oh my God, I think these two things are related, and then something out of the blue comes, and you're like, wow, this is a really cool thing. I had a serendipitous finding once, and I'll tell you about that in class. Somebody remind me. Okay, so I know you all took statistics, and you probably all forgot this part because some of you mentioned that you were a little nervous about data analysis, and I said, no worries, I got your back, I'll help you. But anyway, this might ring a bell, Pavlov, to all of you when I'm going to talk about probability. So you might remember that you did probability, and you did permutations and commutations. I know, it's probably giving you a flashback, but anyway, we're going to talk about that too. But probability theory is the theory of chance. So like, the classic example, you flip a coin and 50% of the time it's going to be heads and 50% of the time it's going to be tails, and that's probability. So that's another goal of science, is to try and figure out the probability of X happening and the probability of Y happening. So just last night I was watching the news, and I was watching the weather forecast for Toledo because I always want to know what's happening with the weather. And instead of telling us, the weatherman, instead of telling us what he thought was going to happen, he had two different maps covering all his bases. And he goes, one system is tracking this way, and if it tracks this way, it'll get Lansing and, Detroit. But here's the other one, and if it goes this way, then we're in trouble, we're going to get a big storm. So he's, instead of saying the probability of us getting snow is X, he was like, I don't know, I'm going to cover both my bases, the probability for this and the probability for that. And I was just laughing, thinking, oh my God. Just say the probabilities. That's the goal of science. And meteorology is a science. So that's how that plays out when you're trying to use science as predictive. Like we really like it every day. We look to see what the weather is. And some of us go, like we've all lived through this at Tiffin. They say the storm of the century, the storm of the decade, and then nothing happens. That's the probability. So they really have to look at their ability to do probability. So that's another part of research. There are also two different types of research, pure and applied. So pure research is doing research just for the sake of doing it, because you're curious, because you want to know the answer, okay? And applied research is you're doing it for a purpose, to solve a problem. So the famous example is, there was this famous book. It was like a hot #1 bestseller back in the day. It was called Principia Mathematica, okay? And it was a famous work, and it talked about, it was Latin for mathematical principles. And it took Europe by storm, I know. Kind of dry, right? But they didn't have like all the books we have today. So they had to go with what they had. Anyway, it was all over the place. Everybody wanted to read it. It was a hot commodity. And the Tsar of Russia was talking to scientists and was saying, okay, here's this thing, gravity. Okay, gravity. So big deal. What is it? What is it? Who cares? How can I use it? And that was the question. How can I use it? So he's asking, what is the application? Applied research. And the scientists who were just doing it for the sake of doing it, because he was curious, said, I don't know, maybe someday it'll be important. The understatement of all time. Okay, so pure research often leads to applied. I think that all pure research will someday lead to applied. But applied research is, I have this issue, I'm going to research how to figure it out. Like I told you guys last time, I had a student who, you know, he took the class and he was like, oh my God, I'll never use this. And then his wife, I met his wife like 5 years later, and she comes up to me, she goes, you made a monster. We have a baby now, and he won't put our baby in any kind of car seat or any kind of device because he has to do all the research because you made him paranoid. So that would be applied research. What is the best, you know, car seat for my baby? That's applied research. You're doing the research for a reason, okay? And it happens to be safety. So all of those kinds of NTSB, National Transportation Safety Board, and the FAA, those kind of places do it for a reason. A lot of government agencies, like the DEA, they're tracking drugs. The Secret Service is looking to track threat assessments. The FBI, they're doing investigations. So all of those things are basically research. So I got news for you. If you have your heart set on being in the FBI or any federal agency where you're going to be an investigator, guess what? A goal of science and research is to investigate. So that's all it is glorified research. So now you better start liking research. And they're going to be really excited. I often get calls from federal agencies that say, who you got that's good? There's my cat right there. See? He's a troublemaker. Anyway, so yeah, research is helpful for investigation, and that's what that is. So you have pure and applied. The last thing for this last part, I'm only going to do 3 tapes, is qualitative and quantitative research. We're really, really, really going to get into that later on in the semester. But quantitative research means basically what it sounds like. You're looking for a numerical answer to a particular question. A qualitative piece of research is not as numerical as quantitative, obviously, and it's looking more at the quality of something or the perceived quality of something. We will learn at the end of the semester how to make qualitative into quantitative and quantitative into qualitative. And hopefully some of you guys will do that kind of research. It's a little bit more advanced, but if you're curious at all, and it really will help you if you are looking at a federal position or a state position, because they really like good researchers, and that will help you. So the next thing on the study guide that hopefully you're printing up and following along is research shock. And I really think that I have already put you in research shock. It is kind of overwhelming because there's a lot to learn in 15 small weeks about research. Don't let it overwhelm you. It's just like any new area. There's a lot of information, and sometimes it does get overwhelming, and people are just like in a state of shock, like, oh my God, it's so overwhelming. But we're going to get through this together, and if you need help, I'll help you, so it'll be okay. We're going to continue on introduction on Tuesday, so I'll give you another video, and we'll continue down on the lecture outline. I'm only going to give you what I talked about today. You'll get the second half on the next time, okay? So I know that was kind of fast, but I only wanted to do 3 videos for today. I know it's a lot to digest, and I'll put a forum question up too. Make sure you do that so that your financial aid doesn't get screwed up and attendance is counted. Okay? So I can't wait to see you guys in person. Anyway, it's a great day to be a dragon. See you later.